Okay, I'm doing one. All right, so here is your in-class lesson. Again, this is more for virtual kids. So those of you that are in class today, we're going to go over this. So those at home, I'm going to kind of go over just on the surface what this is. You'll go more in depth on Wednesday. We'll go more in depth on Wednesday, Thursday, but I want to talk about the zero exponent and the negative exponent. Okay, so and I'll show you a couple different ways with the negative exponent, and it's going to take a little bit of practice. The negative exponent probably causes the most issues, so hopefully this helps a little bit today. So here we go. If a is not 0, so if the base of this is not 0, anything raised to the exponent of 0 is 1. Okay? So why is that the case? Well, let's look at it kind of with things you've learned before, right? You have learned that anything divided by itself is 1, right? 4 divided by 4 is 1. 6 over 6 is 1. X over x is 1. So this, d to the 4th over d to the 4th, is just equal to 1, right? Because we're just dividing some number, whatever it is, by itself. Well, we have come from where now we're subtracting exponents. Right? So when we subtracted exponent, or when we simplified fraction, we subtracted, and that's really the quotient rule. So last week when we were multiplying powers, we added exponents. Well, when we divide powers, we subtract. So this is also the same thing as d to the 4 minus 4. Well, that's d to the 0. These are the same thing. Okay? So now we use that fact to evaluate a lot of things. So here we go. This is m squared times n to the 0. Well, this just becomes m squared times 1. M squared times 1 is just m squared. Notice this all wasn't 1, right? This all wasn't raised to the 0 power, just the n was. This one, 234 to the 0 power, that is just 1. Anything to the 0 power is 1. Now this one's a little different than A. This one, this whole thing inside of here, x times y is all raised to the 0 power. So that's 1. And then the bottom just stays the same, over xy squared. All right. So here we go. Negative exponents. Negative exponents are the toughest thing that we'll do. Out of all the rules that we've done, I think this one's the toughest. So a to the negative power is basically, all we do is flip it over. There's like a magic fraction bar, becomes 1 over a to the m. So we think of this as a to the negative m over 1. So if you have anything to the negative exponent, you can flip it, right? So if it's in the numerator, you flip it to the denominator and make it positive. If you had it in the denominator, if I had this, 1 over a to the negative m, again, I can just flip it. You think of this as if you want to change, all you got to do is flip over this fraction bar. So if you're acting pretty negative and you say, you know what, I want to act positive, then you flip yourself over this fraction bar and you can actually turn yourself positive, right? If you're like, man, I'm sick of being positive, I want to turn myself into just a negative Nelly, well, I could go backwards and flip it back over this imaginary bar that's right here that we don't usually see, and I could go back to this. But these are the same thing. Right? So if I want to make a negative exponent positive, I just have to flip it, basically. All right? So here we go. So 5 to the 3rd over 5 to the 5th, if we do our subtraction rule, right, that is 5 to the 3 minus 5. Right? We take we subtract these exponents, so that is 5 to the negative 2nd power. Okay? That is 5 to the 3 over 5 to the 5th, which is different than 5 to the 5th over 5 to the 3rd. That would be 5 to the 2nd power. Now, when you did this last week with simplifying fractions, you got that answer was 1 over 5 squared, because what we did is we did 5 times 5 times 5 over 5 times 5 times 5 times 5 times 5. We expanded and canceled, right? Well, that is cancel, cancel, cancel. Well, you're left with 1 over 5 squared, which is also 1 over 25 if you want to do 5 squared. These are equal. But it's also the same as this, right? So that's where this subtraction comes in with this quotient rule, all right? But these are equivalent. All right, next one. So here we go, magic fraction bars. 5 to the negative third becomes 1 over, I'm going to become positive, becomes 1 over the 5 to the third power, right? Because if you think of this as 5 to the negative third over 1, it becomes 1 over 5 to the third power, which if you want to evaluate that, that is just 1 over 5 times 5 times 5, which is actually 1 over 125. Okay? This one, m to the fourth, and it says to evaluate with only positive exponents, right? I could have left this as 5 to the third. Well, this one, where you've come from, you're probably going to do this as 1 over 5 m squared, right? Because that's what you've done on practice 4.4. But if you use the 4 minus 6, this is m to the 4, we subtract exponents, that is m to the negative second power, okay? Which is equal to 1, put it over that magic fraction bar, these are equal. M to the negative second power is the same thing as 1 over m squared, okay? Now, if I was to evaluate this, if I do it with my subtraction, right, kind of subtracting our exponent rule, remember there's ones on these, x to the fourth over x to the first is x to the third. Y to the first over y to the second is actually now y to the negative first because of 1 minus 2. But what we do is we flip this over the fraction bar. This is equal to, this stays on top, right? This has a positive exponent, so that stays on top, and the y goes to the bottom, because this is like a 1. Right? We have flipped it over this imaginary fraction bar, right? We put it to the bottom, made it positive. All right, second page. So these that I'm going to do, I'm just going to do these 6, all right? And then your homework is the rest. And the homework's a little more involved, so you may have some questions on the homework, right? The key is just flip it over that. So I'm going to do a couple things here. So for this one, 2 to the fifth times 2 to the negative third is 2 to the what power? Well, using our product rule, right, we add these together. That becomes 2 to the 5 plus negative 3. Well, that is just 2 to the second power. But you could also think of it as 2 to the fifth times 2 to the negative third. So here's part A. Part B, you could also flip this down below. You could flip this to the negative third and put it below. So this is equivalent to 2 to the fifth over 2 to the third and make it positive. Well, 2 to the fifth over 2 to the third, I have 5 2's on top, I have 3 2's on the bottom, I have 2 extra 2's on the top. Same thing. Okay. This one, 2 to the fifth over 2 to the seventh. We use our quotient rule, that's 2 to the 5 minus 7. Well, that's 2 to the negative second power. Okay. But you could also do what we did last week, all right? 7 minus 5 is 2, right? Well, I have 2 extra 2's on bottoms, which those are equal to 1 over 2 squared. Okay? Just remember, there's a fraction bar over this. Magic fraction bar. You can flip it. Next one. 2 to the fifth times 2 to the negative seventh. You want to use the product rule? That is 2 to the 5 plus negative 7. That is 2 to the negative second power. Or using our negative exponents, right? It's 1 over 2 squared, which is equal to 1/4 if you want to even go even further. Okay? Now, D. This one gets a little challenging. There's a couple different ways you can do it. Notice, if you want to subtract these exponents, right? And I don't care which way, if you're good enough, right? If you know that if I have a quotient rule, I could subtract 2 times 5, but it's minus a negative 7 now. So if you're comfortable with your subtracting a negative, and you know that that is 2 to the 12th power, that's fine. Okay. Also, you could think of it as, I could flip this 2 to the negative 7th up to the top and make it positive. So 2 to the 5th over 2 to the negative 7th is 2 to the 5th times 2 to the 7th. Well, now we're back to the product rule. All right. And that is just add the exponents. That is 2 to the 5 plus 7, which is also 2 to the 12. Okay. Next one. 2 to the 5th over 2 to the e. What could this be? All right. You could ask yourself, 2 to the 5 minus what number equals 8? So if you're good enough, you could think 5 to what number equals 8? Or you could flip this in, well, I'll tell you, if e is equal to negative 3, all right, 2, 5 minus negative 3 is 8. Or you could say, okay, well, 2 to the 5th, if I were to flip this up, if this started out negative and I make it positive, right? Well, what's the positive number that this has to be? Well, this has to be 2 to the 3rd. So that makes it 2 to the 8. But your e had to start at -3. If I flip it up over this magic fraction bar, if I want to start negative and become positive, right? E would be -3. Again, that. Okay? Last one. 2 to the 5th times 10 to the -2nd power. Here we go. Magic fraction bar again. Okay? That becomes 1 over 2 to the 5th to the 2nd power. All right? Which is 1 over 2 to the 10th, which is 2 to the -10th. Or you could have done this right from the beginning, right? They just wanted what f was. Well, if you did the power rule last Friday, you should have figured out that you multiply powers. Well, 5 times -2 is -10. Now, I want to show you one more, and we'll do more of this on Wednesday and Thursday, but what if I have like 2x squared y to the 3rd over 4x to the 4th, 3y to the 6th, right? And I have all this raised to the -3rd power. All right? What if I have that? All right. Now, if I had it to the 3rd power, right, it would be just 2x squared y to the 3rd over this, and I multiply it by itself 3 times. That's what you could do, right? And I would probably make this 12. I'd probably actually combine that to 12x to the 4th y to the 6th. But if I had this negative exponent, well, it's not over 1, but what I could do is just flip these, right? So this becomes 4x to the 4th, 3y to the 6th over 2x squared y to the 3rd power, but now it's raised to the 3rd power. Now I've changed this negative by flipping it. So I can just reverse my order, and now you can just expand this, right? And that's probably the best way for you guys to do it now, but I think you're going to see a couple of those on your homework. So I apologize. I know it's 12 minutes long, almost 12 minutes long. It's a little long, but it's going to help you come, especially Thursday when it get more difficult. All right? All right, have a great day. I'll see you in class this week.